National Electrical Code Section 230.7b specifies that independent means of locking off branch circuits is required where the disconnecting means is out of sight of the servicing equipment. Additionally, Section 312.5a states that for overcurrent protection devices rated over 100 amps, the service disconnect and all branch disconnects over 100 amps must be located in the same room or enclosed space. In a situation where a 250 amp main breaker is out of sight of the 150 amp and 100 amp disconnects, and these disconnects are not in the same room or enclosed space as the 250 amp main breaker, the setup would likely fail in inspection based on these NEC requirements. Firstly, the main breaker is out of sight of the branch disconnects. Secondly, the branch disconnects are not in the same location as the main breaker. Thirdly, there is no independent means of locking off the 150 amp and 100 amp disconnects. Possible solutions include relocating the 400 amp panel board closer to the 150 amp and 100 amp disconnects so that they are in the same room or enclosed space. Alternatively, install a visual disconnect switch outside of the building near the 150 amp and 100 amp disconnects, which would provide a visible means of locking off the main breaker remotely. Another possibility is to contact the local authority having jurisdiction, abbreviated AHJ, and request an exception or variance. The AHJ may allow the installation as if it can be demonstrated that it is safe and meets the intent of the code. The primary concern is ensuring safety and compliance with the NEC. The NEC aims to protect people and property from hazards arising from the use of electricity. The requirement for a disconnecting means to be readily accessible and capable of being locked in the open position is fundamental to electrical safety. This allows electricians and other qualified personnel to safely work on electrical equipment without the risk of it being inadvertently energized. When the disconnecting means is out of sight, an independent means of locking it off becomes even more critical. This ensures that someone working on the equipment can positively verify that the circuit is de-energized and locked out, preventing accidental energization from a remote location. The rule regarding the location of overcurrent protection devices rated over 100 amps in the same room or enclosed space further enhances safety and facilitates maintenance. By having all the disconnects in one place, it simplifies the process of identifying and isolating circuits, especially during emergencies. In practical terms, consider a scenario where an electrician needs to perform maintenance on the 150 amp disconnect. If the 250 amp main breaker is located 800 feet away in another part of the building, the electrician would need to walk back and forth to verify that the circuit is de-energized and locked out. This is not only inefficient but also introduces a potential safety risk. If, however, the main breaker and the disconnects are in the same room, the electrician can easily verify the lockout and proceed with the work safely. The intent of the NEC is to provide a minimum standard for electrical installations. While it is possible to request an exception or variance from the AHJ, it is essential to demonstrate that the proposed installation provides an equivalent level of safety. This might involve implementing additional safety measures, such as installing redundant disconnects, providing clear and prominent labeling, and developing comprehensive lockout/tagout procedures. When considering a variance, be prepared to provide detailed documentation, including electrical drawings, load calculations, and a safety risk assessment. The AHJ will carefully evaluate the proposal and may require additional information or modifications before granting approval. The NEC also addresses specific requirements for the ampacity of conductors. For example, Section 310.15 and associated tables such as 310.16 detail how to determine the allowable ampacity of conductors based on factors such as insulation type, temperature rating, and installation conditions. When sizing conductors for the 250 amp breaker and the 150 amp and 100 amp disconnects, it is crucial to ensure that the conductors are adequately sized to carry the intended load without exceeding their ampacity rating. Overloading conductors can lead to overheating, insulation damage, and potentially electrical fires. In addition to conductor ampacity, it is also important to consider voltage drop. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. To minimize voltage drop, use larger conductors or shorten the length of the circuit. The NEC also specifies requirements for grounding and bonding. Grounding provides a low impedance path for fault current to return to the source, helping to trip overcurrent protection devices and minimize the risk of electric shock. Bonding connects non-current carrying metal parts of electrical equipment together, creating an equipotential plane that further reduces the risk of electric shock. When installing the 400 amp panel board and the associated disconnects, it is essential to ensure that all grounding and bonding connections are made in accordance with the NEC requirements. This includes properly grounding the panel board enclosure, bonding the metal conduits and raceways, and connecting the equipment grounding conductors to the grounding busbar. The selection of overcurrent protection devices is another critical aspect of electrical safety. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect conductors and equipment from overloads and short circuits. The NEC specifies requirements for the selection and coordination of overcurrent protection devices. When selecting a circuit breaker or fuse, it is important to choose one that is properly rated for the circuit and the equipment it is protecting. The interrupting rating of the overcurrent protection device must also be sufficient to handle the available fault current at the point of installation. Coordination of overcurrent protection devices involves selecting devices with different time current characteristics so that the device closest to the fault will trip first, minimizing the extent of the outage. The NEC also addresses requirements for arc flash hazard analysis. Arc flash is a dangerous phenomenon that can occur when a short circuit or ground fault creates an electrical arc. Arc flash events can generate intense heat and pressure, causing severe burns and other injuries. The NEC requires that electrical equipment be labeled with arc flash hazard information, including the incident energy level and the required personal protective equipment, abbreviated PPE. An arc flash hazard analysis should be performed to determine the appropriate PPE requirements for each piece of equipment. In addition to the NEC requirements, it is also important to comply with any applicable state and local electrical codes. State and local codes may be more stringent than the NEC in certain areas. It is always best to consult with the local AHJ to determine the specific requirements for your installation. When working with electrical systems, it is essential to follow safe work practices. This includes de-energizing circuits before working on them, using appropriate PPE, and following lockout/tagout procedures. Only qualified electricians and other trained personnel should perform electrical work. Remember, electricity can be dangerous, and even a small mistake can have serious consequences. Always prioritize safety when working with electrical systems. When installing a 400 amp panel board, it is crucial to consider the physical space requirements. The panel board must be installed in a location that provides adequate working space around it, as specified by the NEC. This working space must be clear of obstructions and provide sufficient room for electricians to safely access and maintain the panel board. The NEC also specifies minimum headroom requirements for electrical equipment. The panel board must be installed in a location where there is sufficient headroom for electricians to work comfortably. The NEC also addresses requirements for the identification of circuits. Each circuit breaker or fuse in the panel board must be clearly labeled to indicate the equipment or area it serves. This helps to prevent accidental de-energization of critical circuits and facilitates troubleshooting. The labels must be durable and legible, and they must be updated whenever changes are made to the electrical system. The NEC also provides guidance on the proper installation of conductors in raceways and conduits. Conductors must be installed in a manner that protects them from physical damage and prevents them from overheating. The NEC specifies the maximum number of conductors that can be installed in a given size of raceway or conduit. When pulling conductors through raceways or conduits, it is important to use a lubricant to reduce friction and prevent damage to the insulation. The NEC also addresses requirements for the support of raceways and conduits. Raceways and conduits must be securely supported to prevent them from sagging or becoming dislodged. The NEC specifies the maximum spacing between supports for different types of raceways and conduits. The NEC also provides guidance on the proper use of flexible cords and cables. Flexible cords and cables are typically used for temporary wiring or for connecting portable equipment. The NEC specifies the types of flexible cords and cables that are permitted for different applications. When using flexible cords and cables, it is important to protect them from physical damage and to avoid overloading them. The NEC also addresses requirements for the installation of electrical equipment in hazardous locations. Hazardous locations are areas where there is a risk of fire or explosion due to the presence of flammable gases, vapors, or dusts. The NEC specifies the types of electrical equipment that are permitted in hazardous locations and the special installation requirements that must be followed. When installing electrical equipment in hazardous locations, it is essential to consult with a qualified electrical engineer to ensure that the installation complies with the NEC requirements. The NEC is a comprehensive document that covers a wide range of electrical safety topics. It is essential for electricians, electrical engineers, and other qualified personnel to be familiar with the NEC requirements. The NEC is updated every 3 years, so it is important to stay current with the latest edition. The NEC is not a substitute for good engineering judgment. It is important to use your knowledge and experience to make sound decisions about electrical installations. If you are unsure about any aspect of an electrical installation, consult with a qualified electrical engineer. The NEC is a valuable resource for ensuring electrical safety. By following the NEC requirements, you can help to protect people and property from hazards arising from the use of electricity.